In this video, I'm going to talk more about the strengths of acids and bases. You've probably heard me use the terms weak and strong in previous lessons when referring to acids and bases. And what does that actually mean? Like when I say a strong acid, what does that mean compared to an acid being weak? We can kind of think of in our mind that a strong acid might maybe, be a little bit more corrosive, or it might have a lower pH, or it would maybe react more vigorously than its weak counterparts. And all those things can be true, but once again, we kind of need to think through a theory as to why an acid might be strong or weak. We're not going to dive into all the details of what makes an acid strong or weak. We just really want to provide a definition right here about, what is a strong acid and how is a strong acid different from a weak acid. And the same applies for bases. The same kind of lesson applies for bases. So let's start off by having a look at strong and weak acids. So on the left-hand side of the page, I've got a graph that's going to show the reaction of a strong acid. And on the right-hand side, I've got a graph that's going to show the reaction of a weak acid. So in general, with strong acids, they are going to react with water, and this could be G or L. Okay, so a strong acid could be gas or in the liquid state. I'm going to react it with water, and generally strong acids are almost 100% ionized in water to produce hydronium ions and the anion. And the anion is whatever is left over after this acid has given up its hydrogen. So think back to an earlier lesson where we talked about hydronium ions and how acids are those substances that react with water to produce hydronium. They do this by giving up a hydrogen. The hydrogen reacts with water to make hydronium, and what remains of this entity, HA, is the anion. It's an anion with a minus charge because it's given up a proton, which is just one positive charge, one proton. One positive charge. That's right. So in general, A is not referring to any specific element. A is talking about, is a placeholder for a general anion that is part of this acid. And I'll show you some examples of what can be A. But really we're paying attention to the extent of the reaction. And really the strengths of acids and bases really comes down to the extent to which an acid ionizes or dissociates in water. So with a strong acid, this is almost 100%. So let's say before I put it in water, all the molecules are in this particular form, HA. Once I add water, almost 100% of these HA molecules now turn into hydronium and the anion. And I've got a very tiny amount of this. So very few of these HA entities remain as HA. Most of them, almost 100%. I'm not saying all of them, because there's always going to be like a tiny bit left over, but that's something that we're going to see a little bit more closely next year if you were to take Chem 30. But we can basically assume it's as close to 100% as you can get. They turn into hydronium and the anion. So it's almost 100%. So it's a little bit like, you and your friends, you're at an outdoor swimming pool this summer, hopefully, unless we're all quarantined. But let's say we're out at a swimming pool and there's a big 10-meter diving board. And if all your friends are really courageous, you're all going to dive off that board and end up in the pool. So there's almost complete buy-in. There's a complete transition from HA to hydronium and anion. Everybody ends up in the pool. Okay, so this reaction is 100% in the forward direction. Strong acids love giving away these hydrogens. They love reacting with water to produce hydronium, so much so that there's none of the HA entity left over. An example of this would be hydrogen chloride. If I take hydrogen chloride, and in this case A is represented by chlorine. Hydrogen chloride plus water. I draw it with a single arrow because this doesn't go backwards. We're all in. We're going all or nothing. Okay, hydrogen chloride plus water turning into hydronium and chloride ions. We're not holding anything back. So hydrochloric acid, okay, is the acid that results when we dissolve hydrogen chloride in water. And it's what we call a strong acid. This is a strong acid because it has a complete ionization in water. So you can imagine you start out with, all molecules are in the HA form, but once you put it in water, all of these HA molecules give up that proton, and what is left over is the anion and the proton reacting with water to make hydronium. So it's almost like 100% conversion here between these two entities. Other strong acids here are nitric acid is a strong acid, so it does the same thing. Hydrobromic acid, it's also a strong acid. Hydroiodic acid is a strong acid. Sulfuric acid and perchloric acid is a strong acid. So these 5 and hydrochloric acid, they make up 6 strong acids. You have your data booklet hopefully with you, and you can actually find these 6 strong acids in your data booklet because they can be found right here at the top. Next year in Chem 30 we'll pay attention to what this K value means over here, but notice they all have the K value that's very, very large. We'll dive into that next year. You don't really need to know anything about that in grade 11, but for a reference, you don't need to memorize these. You can look in your data booklet here and you can see, okay, here's my 6 strong acids, and you need to just know that they ionize 100% in water. So that being said about strong acids, 100% in water, maybe pause the video and think about what a weak acid would be. So a weak acid, when we dissolve it in water, is going to be a little bit different. Instead of a 100% ionization in water, we get something that's maybe closer to 1%. We get what's called a partial ionization. Maybe only 1% of these acid molecules, sorry, I did that in the wrong color. Maybe only 1% of these acid molecules will actually give up their proton and form hydronium ions. So this is kind of what separates the strong from the weak. Strong acids love giving up that proton. They love making those donations of protons. Weak acids don't really love doing it as much. So much so that they will they will only partially dissociate or ionize with water. So, and in this one I draw it with reversible arrows because it's really the forward reaction here. So this turning into our products doesn't occur as much as we would get with this one. Here the forward reaction is 100%. It just goes this way. Whereas here there's a little bit of going forward, there's a lot of going backward. But we still do make a little bit of hydronium ions and the anion. So we still make a little bit, and it's enough to make the pH acidic and show some acidic properties, but we're not getting as many ions being produced here. So an example of this would be, one we've seen before would be carbonic acid. So carbonic acid in water, it's just going to give up one of its protons here. And we have the anion left over. And this is maybe closer to about 1%. Okay, we're not going very far. So, most acids tend to be weak acids, and if you look in your data booklet, you'll see anything that's not a strong acid is basically a weak acid. So that means a lot of acids that are part of your take part in your physiological reactions within your body, the biochemistry within your body. Most of those acids are weak acids. So some examples here of weak acids, just kind of look through your data booklet. There's a whole bunch, but we'll just go through some of them. This is one. This is known as acetic acid. So that's the acid that's part of vinegar, and it gives up that proton there. It's a very weak acid. We can sometimes they're written a little differently, okay, and it's not always easy to define, identify which hydrogen is given up from the formula to water, but this one's called formic acid or methanoic acid, and it gives up this one right here. So introducing a little bit of complexity, like the hydrogen is not always the one that's found right at the start of the formula. So, but anyway, like that, this is the difference between strong and weak acids. So remember, strong acids are complete ionization, whereas weak acids will be very, very minimal, less than, much less than 100%. Okay, and realistically, we're looking at maybe close to 1% and smaller. So there you go. That's the difference between strong acids and weak acids.